look at geological features around the world, many of them are radically different from anything being formed today, like thick mud layers over continents, or coal seams covering entire states, or fossil graveyards, or frozen mammoths, or miles of underground cave passages, or thick ice sheets moving over continents, or craters of supervolcanoes, or canyons cut thousands of feet deep. It looks like the present is not the best way to explain the geological features of the past. The Bible, however, offers another way to explain features from the past. Noah's flood was a global judgment, a violent catastrophe upon the earth. Based on this truth revealed in God's Word, scientists are developing a series of models to explain how the flood and its aftermath could have shaped the world today. In the course of the flood, erosion washed away mountains of rock in some places, while miles of mud and sand were piled up in others. The Earth's crust was thickened in some places and thinned in others. Like jostled ice cubes sink and bob up to their proper level in the water, some sections of land sank after the flood, while other sections rose. Supervolcanoes and superquakes rocked the world after the flood. As the centuries passed, the catastrophes became rarer and smaller. Modern earthquakes and volcanoes are dim leftovers from this violent period of Earth history. Warm oceans after the flood produced violent weather, possibly even hypercanes, huge hurricanes like the Great Red Spot on Jupiter, which may have persisted for centuries. High rainfall after the flood filled enormous lakes, eroded large canyons, and carved cave systems. As animals left the ark, multiplied and spread over the earth, many of them were preserved as fossils. Some were buried in ash and mud. Some were preserved by unique chemical conditions, and others were frozen. Truly, the present is not the way things were in the past. Instead, the Bible is the key to help us understand geological features around the world. On May 18, 1980, Mount St. Helens, located 95 miles south of Seattle, Washington, erupted. The eruption was triggered by an earthquake centered beneath the mountain that measured 5.1 on the Richter scale. The lateral blast swept out the north side of Mount St. Helens at 300 miles per hour. With temperatures as high as 660 degrees Fahrenheit and the power of 24 megatons of thermal energy, it snapped 100-year-old trees like toothpicks and stripped them of their bark. Before the famous eruption at Mount St. Helens, scientists were mostly familiar with slow-acting examples of geologic change. But at Mount St. Helens, geologists watched the Earth's surface change quite rapidly. Icebergs were buried in hot avalanche material. They melted and formed badlands in days. Eruptions on May 18 and June 10 produced fine layers in hours. On June 10, mud flows cut zigzag canyons 100 feet deep in soft sand and mud, complete with perpendicular side canyons. Canyons that are reminiscent of the geography of Grand Canyon, only 40 times smaller and clearly produced within hours. Mud flows over the following decade cut hundreds of feet into solid rock in just days of cutting time. Fallen trees formed a log mat on the surface of Spirit Lake and dropped bark to the bottom of the lake, accumulating up to 3 feet of bark peat in just a couple years. And vertically floating logs sinking to the bottom of the lake resulted in buried trees in only a decade, similar to the trees of Yellowstone's fossil forest, which are also buried in volcanic layers. Even though Mount St. Helens is a very small catastrophe compared to the flood, or the major catastrophes immediately following the flood, it provides a better clue to what happened in those times than the slow geologic processes which are most commonly seen in the present. Rock layers are visible in mountains, plateaus, and canyons all over the world. Where did these rock layers come from? Present processes aren't the answer. Today, sand and mud are usually deposited in thin layers along the outer edge of continents, and the formation of fossils today is rare. But somehow in the past, thick layers of sand and mud were spread across entire continents and filled with well-preserved fossils. Noah's flood suggests a way to explain these puzzling features. Flooding the continents, for example, could carry sea creatures many hundreds of feet above present sea level. Andrew Snelling is a PhD geologist from Australia who has spent over 30 years studying rocks, working in the field and in the lab.
We find marine creatures buried at the top of the Grand Canyon, which is over a mile above sea level.
A global flood could carry sand and mud enormous distances.
Some of the sand grains that are in the Navajo sandstone had to have come from the Appalachians. But what river or what process today is carrying material from the Appalachians to the southwest?
A global flood could quickly lay down thick layers of mud and sand, burying even giant animals and tall trees.
We've got coal beds with trees sitting on them, and these trees, tree stumps, go through many strata, which means that before they could rot, you had to have lots of sand and mud coming in quickly. Several places in the Grand Canyon, 4,000 feet of different types of sand and mud and lime had been bent, and they've been bent while they're still soft. Both the bottom layer and the top layer are all bent the same way, which means that the whole sequence of 4,000 feet of sand and mud and lime had to have been laid down very quickly by the waters and then bent very soon afterwards.
A global flood could form thick layers across entire continents.
In the Grand Canyon area, we've got limestone bed, the red wall limestone. The same limestone can be found over here in the eastern United States.
A global flood could cut deeply and widely.
We've got this huge flat surface at the rim of the Grand Canyon, which goes for thousands of square miles, where waters on a great scale over a vast area just swept over it and swept everything clean.
None of these processes, deep, wide erosion, or thick, rapid layering, or continent-wide distribution, or lifting of marine organisms above sea level, or sand carried across continents, occur in the present. Radically different processes are required, such as occurred during Noah's flood. Dead organisms usually don't last long. Scavengers and bacteria consume them quickly. Soft tissues rarely last more than days or weeks, and hard parts like bones or shells only a month or two. But the rocks of Earth contain billions and billions of fossils, and in many places, millions of fossils are exquisitely preserved, even soft parts. How could this be? To preserve a body, it needs to be put in a safe place. Extremely cold or dry places would protect them, but most organisms don't live in those conditions. There is another solution: rapid burial. If a body is sealed from oxygen and out of reach of burrowing animals, then it has a good chance of fossilizing intact. Rapid burial is uncommon today, but there's much evidence of massive burials in the past. Not only are many fossils well preserved, they're found amidst very fine sediment layers. Fine layers rarely last in the present because all sorts of animals are digging around in the mud and soil, searching for food. In just a few weeks or months, the original layers are destroyed. But in the fossil record, churned up sediments are rare. If these sediments were laid down rapidly, however, they'd prevent burrowers from doing their job. And there are thousands of feet of such layers in the fossil record all over the world. This suggests that moving water laid down mud and sand rapidly over a wide area, and the process lasted several months. A year-long global flood, as described in the Bible, is the best explanation we know for the well-preserved fossils and fine layering throughout the rocks of the earth. Coal appears in vast deposits scattered over the continents. It is typically thought that such deposits require many thousands to millions of years to form. 10 feet of plant material is needed to make 1 foot of coal. Evolutionary geologists teach that most coal deposits are basically a result of peat building up in swamps over millions of years. And since peat accumulates very slowly in modern swamps, long periods of accumulation would be required at modern rates. But forming coal this way has problems. For example, the top and bottom of coal seams are usually flat, and thin layers of mud are often found within coal seams. In the present world, however, roots of plants in the swamp break up the peat layers and mess up any mud layers which might form. Tree trunks especially penetrate the swamp peat, making it very uneven. Apparently, no modern process can explain how coal originated. The flood of the Bible, however, may provide an explanation. In the course of the flood, weeks of unceasing rains eroded away soil and plants, and rising seas and tidal waves destroyed the forests of the world. Some plants would be buried in place. Some would be ground up and destroyed. Most, however, probably floated atop the floodwaters until they became waterlogged and sank to the bottom. A continuous rain of sinking plants could produce the thick layers of plant material needed to form coal beds. Undisturbed by growing plants, such layers would have flat lower and upper surfaces, and in between could be undisturbed layers of mud. Bark rubbing off logs would explain coals made of bark. And vertical trees sinking would explain stumps sitting atop coal layers without penetrating them. Both have been observed at Mount St. Helens. The flood provides an explanation for the origin of coal, consistent with an Earth only thousands of years old. The enormous coal reserves on our planet are a reminder and tribute to a beautiful and bountiful world now lost.